Let's say in the Young's double slit interference experiment, if the source S is a monochromatic source S is not placed at the perpendicular bisector of the two slits S1 and S2. That means it is not placed at exactly at midway between S1 and S2. Somewhere it is being moved downward or taken up. Okay, so this is the conventional setup. In conventional setup, what do we see? We see that S1 and S2 is same. That means S and S1 is equal to S2. And also we see that S1O is equal to S2O. So all the secondary wavelets that is originating from S1 and S2 will reach O with zero path difference, and they will form this central bright fringe. That is what we have learned in Young's double slit experiment, and that is how the central bright fringe is produced, central maxima is produced. Now what if instead of keeping the S as the perpendicular bisector, we move it up or down? If we take it down or up, let me show it here. What do I mean? In this case, well, let me say I bring the S down. The source S is somehow brought down. The source S is brought down by a distance y. So this new central maxima, what will happen? What will happen to the end? What will happen to the pattern of the interference pattern on the screen? So you see, in this setup, what is happening now is that S1 dash and S2 dash will not be same, not same distance. S1 dash S1 is not equal to S dash S2. Also S1O dash is also not equal to S2O dash. However, the secondary wavelets originating from S1 and S2 will have no difference in path difference. They will reach at O dash. They will form the central bright fringe little bit up, because there will be no path difference between them, because this length, the overall length, you go from S1 dash S dash S1 to O dash and S dash to S2 to there, all will be same only. So as well, the path difference will be they all will reach at the same path difference, covering the same path difference. So the only thing what will happen is that the central maxima and as well as the whole fringe, whole interference pattern will get shifted up by certain angle. You can also see from here that this angle is phi, is exactly vertically opposite angle will be phi. So this angle, both of them will be the same. As both angle will be same, the whole interference pattern will get shifted by this angle phi. So in short, we can say that even if we move the source, monochromatic source S dash somewhere along this line, or we move here and there, we will see the pattern is only going to shift up and down based on the angle that is subtended here. Correct? So as you can also see one more thing, that the secondary wavelets originating from S dash will reach S2 first. Okay, because the path here is less compared to the path over here. Hence, however, the secondary wavelets which will start from S1 and S2, when they reach, they will have no path difference. As a result, they will form the central bright spot, the central maxima. Only the difference is that it will get shifted by this angle phi. Got it? So this is how, if you change the setup, if you modify the setup, there will not much difference in the interference pattern of the Young's double slit experiment, or the interference pattern of two sources S1 and S2 in YDAC.